Hi grade 12s and welcome. In this video we're going to solve the Mathematics Paper 2 May-June 2023, which is also the supplementary examination paper. Now let us go straight into question 1. So in question 1, the owner of a small company wishes to establish whether advertising in a regional newspaper is effective. The table below shows the amount spent on advertising and the corresponding sales figure for the last 9 years. Alright, so we have 9 data set. Determine the equation of the least squares regression line for the data. In order to determine the equation of the least squares regression line, we're going to feed the data into the calculator and we're going to use this equation and get the answers. So y is equal to a plus bx. Now in the calculator is shown as capital A and capital B. So if you go to mode, you go to stats, and if you press option number 2, you're getting XY. You see frequency here, press shift mode, scroll down to stats and select off, press number 2. Right, so you only see XY now. So I'm going to enter all the X values, 21,300. Then we have 23,700, 24,800, 35,40, 24,100, 40,680, 22,400, 35,250, 29,110. Right, so I hope I've entered everything correctly. I will check all my values as well. It's important to double check. Next one is 311,500, 326,700, 349, 200, 470,000, 316, 100, 564, 200, 314,000, 314,000, 487, 300, 392, 900. Right, so I've got 9 data set. Let me just double check everything if I've entered them correctly. So we got 21300, 311, 500. That's correct. 23,700, 326,700. Then we got 24,800, 349, 200. Then 3540, 470,000. 24,100, 316, 100, 4680, 564, 200. Make sure you check all the coordinates. I'm here now. 22,400, and I've got 314,000, 35,250, 48,000, 487,300, 29,110, 392, 900. I think I'm good to go. Now you go to shift 1. You go to regression option number 5 and press option number 1 for A, and we're getting an answer of 1730,22. Right, so 1730,22 plus, I'm not sure whether it's plus or minus, we'll check. We want the gradient now. Shift 1, option number 5 and option number 2. Right, so we're getting 13,96x, 13,96. Right, so I hope you guys understood that. That's my equation now. Predict the sales for a year in which the company will spend 28,500 on advertising. So advertising expense is 28,500, so you just need to enter it into X and get the answer. So Y is equal to 1730,22 plus 13,96 times 28,500. Right, so I'm getting an answer of, let's put this in. I think we need the, okay, let's just enter it. 1730.22 plus 13.96 times 28,500. Right, so I'm getting an answer of 399,590,22. 399,590,22. Right, so I hope you guys are understanding. 399,590,22. Write down the correlation coefficient for the data. To find the correlation coefficient, we just get it's the value of R, which is on the calculator. It represents the strength of the relationship between X and Y variables. So you go to regression and press R, option number 3. And I'm getting an answer of 0.98. So there's a very strong positive, right? 0.98. Describe the association, right? Association between the amount spent on advertising in the regional newspaper and the, so what you're gonna write? There is a very strong positive, strong and positive, okay? Why it is strong? Because it's close to 1. Strong positive linear, there is a very strong positive linear relationship between advertising and sales, between advertising and sales, right? So I hope you understood that. You're just basically explaining the correlation coefficient. Remember, as you get closer to 1, you get stronger, right? From 0 you need to go this way. So as you get closer to 1, it's stronger. I'll use the term very strong from like 0.8, in between 0.8 and 1. Right, closer to 1 you'll use very strong. Closer to like 0.85 and stuff, I'll just use strong. Remember, 0.5 is weak, so you have to say strong positive. Is because it's 0.98. You have to say positive linear relationship. So these are the keywords. You have to say positive linear relationship, right? And what's the strength, right? Whether it's positive or negative or very strong, weak, moderate, you need to say all that. Right, so I hope you guys understood that. Moving on to the next question. The profit the small company made over the same 9 years is given in the table below. So that's a profit made. So let's see what's the profit made. Now we're going to re-enter all these data because they want the mean profit. They want the average. So mean, and they want standard deviation. You can just use a calculator and write down the mean, right? And standard deviation is sigma, right? So we're going to use standard deviation symbol here and the mean symbol there. So let's enter all these values now. You go to mode stat, which is option number 3. Select one variable, option number 1. Now you only see X values, so 110750, right? Then we enter 107,376, 107,376, 152,338, 244,480, 144,021, 275,994, 121,900, 207,636, 187,700. Right, so we have 9 data set. Please double check all your data that you entered them correctly. Press on and go shift 1, go to var, option number 4, press option number 2 to get the mean. So we're getting 172,466, 172,466, comma, it is 466, comma, 11, right? And the standard deviation is, put your calculator on again, shift 1, press option number 4. Standard deviation I'm getting is, choose option number 3, alright? So I'm getting 56,950, 56,950, comma, 56,950, comma, 09. Right? Now that's your answers. Determine the number of years in which the company made a profit that was greater than 1 standard deviation above the mean. Determine the number of years in which the company made a profit. So over the same 9 years is given in the table below. So this is each year for 9 years, alright? Number of years in which, so how many data values is above 1 standard deviation of the mean, alright? So above 1 standard deviation, like I said, above 1 standard deviation of the mean. So I'm just going to draw a number line to explain this to you, how we're going to calculate this. We know the mean is in the center, right? So what's the mean? 172,466, and one standard deviation above the mean is somewhere around here. One standard deviation above the mean is all these values. We want to know the number of values here. So we're going to say x bar plus one standard deviation. That value is going to give me, we're adding those two up basically. So let's just say on, right? So we're taking 172,466.11 plus 56,950.09. Right, so I've got an answer of 229,416.20. Right, so that's the amount I've got. I want to look at all the values now above this amount, 229,416. So it can't be this one, it's not that one. Was greater than one standard deviation above the mean. So we're looking for all values greater than this. Right, looking for values greater than this. 152, 244. So 244 is greater. 275 is greater. 207 no. 187 no. So only 2. So determine the number of years. 2 years. Okay. So the answer is just 2 years. I hope you guys understood that. Moving on to the next problem. The ages of the people who attended a music concert was summarized in the table below. Right, so these are the age, these are the number of people. Write down the modal class of the data. Modal class is the interval that gives the most amount of frequency. Right, most amount of frequency is 90 here. So the modal class is 35 to 45. So we just need to write down 35 to 45. 35 to 45. Remember, 45 is including and 35 is excluding, so it's the other way around. 35 to 45. Okay, how many people attended the music concert? How many people attended the concert? We can add up everything here. Let's just do a cumulative frequency, okay, because we might need it. So I'm going to do a cumulative frequency. That's 20. 20 plus 25 is 45. 45 plus 60 is 105. 105 plus 90 is 195. Right, 195 plus 55 is 250. 250 plus 40 is 290. Right, and plus 30 is 320. Let's see, 20, 45 and 60 is 105. 105, 90, 195. 195 and 55, that makes it 250, 290, 320. Or you can just add up everything. Right, so we've got 320. So how many people attended the music concert? 320. Now, next question, 2.3. On the grid provided in the answer book, draw a cumulative frequency graph to represent the above data. Now, that's the reason why I put the cumulative frequency here. So instead of totaling all this up, I just totaled cumulative frequency way, where I took 20, transferred the 20 there, then add up. And now to draw the cumulative frequency graph, we need to take all the cumulative frequency values. So it's upper class boundaries and cumulative frequency. So remember, these are the x points and these are the y points, and there's a point before this. The x point before this will be 0 and 0. So remember to start at 0, 0. The thing is, should we start at 0, 0 or should we start at 5? And yeah, we should start at 0, 0. Should we start at 0, 0 or 5 and 0? Okay, we can see the minimum value is 5 actually. Alright, so because if you're looking at in terms of the context of the problem, we have 5 here. The ages of people who attended a music concert was summarized in the table below. So the minimum value has to be 5. Right, so obviously someone, you can't get that point. It doesn't exist, 5 and 0, logically. Alright, so so the minimum point will be 5 and 0. Alright, so remember to take logic into account as well. Obviously, if it was class marks, then you would put minimum value 0 because that's marks. Anyways, this is age, and read the context of the problem. Right, so on the grid in the answer book, let's draw the Ogive curve. I've got the grid here from the answer booklet. Alright, so we need to go and plot all these data set. So we need to plot 15 and 5 and 0. So first 5 and 0, right? So 5 and 0 will be midpoint, so that's 2, 4, 6, 8, 10. So 5 and 0 should be right here in between. That's 5 and 0. Next point that I'm going to plot is 15 and 20, 25, 45. 15, 20, 15 and 20. It's going to be in between, right? So 15 and 20, because this is 10, 10, 20, 30, 40, 50. Oops, I put 30. Supposed to be 15 and 20, so it's going to be 10, 20. 15 and 20. Next point that we're going to plot is 25, 45. 25, 45. Is it 25, 45? Upper class boundary is 25 and cumulative frequency is 45. So 25 and 45. 25 is going to be in between here, and 45 is going to be between this and that, exactly in the dead center. Alright, 25, 45. Then we have the next point, which is 35 and 105. 35, 105. 35 and 105. Exactly in the dead center. 35, 105. Then we have 45 and 195. 45 and 195. Somewhere close to 200, right? 195 is going to be 190, 195. Dead center there. Then 55 and 250. That's a nice point. 55 and 250 and 55 will be right there. Right? 55 and 250. Perfect. Next point. We got 65 and 290. 65 and 290. 65 and 290 will just be under 100 here. 65 and 290. So that point right there. 65, and then we have last one, 75 and 320. 75 and 320. That's a nice point. 320 is going to be just above this dark line here. 310, 320. Okay, and that's the last dot that I plot in. Right, so I hope you guys understood this. Now we're going to join up all these dots and draw the ogive curve. Right? Please draw it freehand. Obviously you have more, right? You can draw it much better. 1 second, just trying to get that curve right. Right, so I almost have my ogive right. Okay, so I drew my ogive curve. Perfect. Next question. So that's your ogive curve. Next question. Use the cumulative frequency graph to determine the median age. Median age is the middle value, right? Median age of the people who attended the music concert. So first we're going to find the median position. So Q2 position, which is the second quartile. It's going to be half into 320, so I'm going to get 160th position. Okay, now if you're finding quarter, then you're going to have quarter into 320. If you're finding the 75th percentile, in other words the IQR, in other words if you're finding Q3, then you're going to say 3/4 into 320. Right, so the 160th position, I have to read off the value on the x-axis, so this implies the median, right? So the median is now equal to, I'm going to get it from the graph. So I need to go at 360. Alright, so 160 is a line right here. Let me draw it in red for you. Right, so 160 is right here, right? And we're going to read off the value just now. Okay. Take out all these unnecessary lines. Right, so and I'm going to bring this down. 160th position, so we want the median age, okay? Right, so it looks like as if it's 40, 41, right? So remember the they will give you the benefit of the doubt as long as you show the working, right? So I think the median age is 41, right? So I've got an answer of 41. So I've got a median age which is 41. I hope you guys understood that. Right, so let's move on to the next problem, which is question number 3. In the diagram, right, so we have this diagram here. It's more like grade 11 work here, right? So in the diagram, the equation of line AF is given, right? So in other words, the gradient is -1. B is a point on the x-axis, B is a point on the x-axis. We got the angle of inclination, we can say tan of this angle and get a gradient for this line. We have a point on that line. Hold on. Alright, so we can get the gradient of this line, we can transfer the gradient from here to there. Okay, anyways, let's carry on. X-axis is the midpoint of the straight line A, B is a midpoint, alright? And C. B is a midpoint of A and C. The angle of inclination of AF and AC are 63,43 degrees. AF and AC. AF. Where's AF? The angle of inclination of AF and AC are alpha and 63,43. AF cuts the x-axis in E. Alright, so E is the x-axis. D is a point on such that D is parallel to DE is parallel to AC. We got parallel lines here, so we can transfer the gradient from here to there. Anyways, let's solve these problems. 3.1.1, calculate the value of t. How are we going to calculate the value of t? First we need the gradient of this line or the equation of this line, and we can just substitute and get the value of t. Let's see. 3.1.1. Right, so the gradient of line AC is tan theta, which is 63,43 degrees, and that answer should give me, let's put it on the calculator, tan 63.43. Right, so I'm getting mode 1 again, tan 63.43. Right, so I'm getting an answer of 1,999, so that's approximately 2. Right, so I've got y equals 2x plus c at a, which is -1, and t. Okay, so we're going to substitute my t, y value is t. 2 times -1 is -2. Wait, hold on. To calculate the value of t, we substituted in the wrong one. To calculate the value of t, we got an equation on this line. We can just substitute a inside this one. Right, so we got y equals -x minus 11 at a, which is -1, and t. Right, so t is equal to -1 is 1 minus 11. -1 is 1. 1 minus 11 is -10. So the value of t is -10. Next one, let's calculate the size of alpha. Remember, t is -10, so we're going to put that down. Can the value of t be -10? Yes, because now this line carries on down. That's -11 is a y-intercept, so it's correct. The size of alpha. Now, to find the size of alpha, 3.1.2. Remember, gradient is equal to tan theta, or tan alpha is equal to gradient. We say tan alpha is equal to the gradient. What's the gradient of this line? Remember, alpha is here, so the gradient on this line is -1. Now, tan of -1, tan of 45 is 1. But now 45 degrees is the angle on the inside, so this is going to be 180. So alpha is equal to 180 minus 45 degrees, which is 135. So I've got 135 degrees for alpha, which is the angle of inclination. Okay, since I have an angle of inclination, just 1 second. Angle of inclination, let's work it out. Shift tan 1. So I'm getting 45, and tan is negative in the second quadrant, so 180 minus 45. So I've got 135. I hope you guys understood that. The gradient of AC. To find the gradient of AC, that's simple, right? I started off with that, right? So gradient of AC is gradient tan 63,43 degrees, and remember we had the answer of 1,999, so the gradient is just 2. So the gradient of AC is equal to 2. Okay, now let's move on to the next problem, which is 3.2. Determine the equation of the line AC. Now we can find the equation of the line AC because I didn't have that coordinate, remember, right? So the equation of the line AC is y minus y1 equals m into x minus x1, right, at a, which is -1 and -10 at a. And remember what is m? M is just 2, right? M is equal to 2. Y minus y1 will be y plus 10 equals m, which is 2, into x plus 1, because minus 1. Remember, this is your x value, this is your y value, and that's your m. Right, so we're going to open this up. We'll get 2x plus 2, open the brackets up, and take the 10 over minus 10. Right, so we got 2x minus 8. Y equals 2x minus 8. Right, so I hope you understand this. I hope you guys are understanding. So we got 2x minus 8, right? Next question. The coordinate of C. What's the coordinates of C? Coordinates of C, that's the end point. So let me just copy this, right? Because we have an equation of the line, right? We already have the equation of the line, so we can get the midpoint, right? So think about it, the coordinates of C. How are we going to find the coordinates of C? Right, so in order to find the coordinates of C, we got A, we just need to find B, right? Because B was a midpoint. So we're going to say 2x minus 8 is equal to 0. So x is equal to 4. So the coordinates of B is 4, 0. Okay? That's the coordinates of B, which is 4, 0. Now remember, we're finding midpoint. So A is the end point, which is -1 and -10. Right, so B is a midpoint, and C is an unknown. Call it A and B. Right, now, or call it x2, y2. Right, call it x2, y2. Now, -1 plus x2 divided by 2 is equal to 4. Right, so we're adding the end points and dividing by 2 to get the midpoint value. Right, so 2 times 4 is 8, 8 plus 1 is 9, so x2 is 9, right? Now to find y2, we're going to say -10 plus y2 divided by 2 is equal to 0. Now 2 times 0 is 0, so y2, just take the 10 over, y2 is equal to 10. So what's the coordinates of C? 9 and 10. I hope you guys understood that. Alright, so we have the coordinates of C, which is 9 and 10. So let's put it on our original diagram, 9 and 10. I don't think we need to use this further. Anyways, let's just write it out. Coordinates of C is 9 and 10. Right, so, and our next problem now. Next problem is the size of FED. The size of FED. What are we doing with FED? FED, that's the size we want. The size of FED. Yeah, let's try to understand this problem also. Right, so how are we going to find the size of angle FED? FED is this entire angle. Alright, so let's try to find the angle of inclination of this line now. Example, what am I doing? I'm just intersecting this. I'm just going upwards here. Right, so that's the angle of inclination here. Then I can do vertically opposite from here to there. Can I do vertically opposite? I just want to see if I can do vertically opposite here. Let me extend this line further up. Right, so is this vertically opposite? Yes, this is vertically opposite. So I can take the gradient of ED. What's the gradient of ED? Gradient of ED is the same as the gradient of AC, right? And that answer is equal to 2 because ED is parallel to AC. Now we can say tan beta is equal to 2. So we can just see this. You can just take corresponding angle, right? So there was no reason to take gradients then. We could have just took corresponding angle. Remember this line, ED is parallel to BC. Now I think we should say that. Alright, so let's put the previous thing back. Alright, so tan beta equals 2 because I'm trying to get this angle here. So beta is equal to same 63,43 degrees. Now I'm going to take vertically opposite here. Right, so it's going to be 45 degrees. Remember we said this angle was 45 to find that 35. So I'm going to get FED, angle FED. Or you can take what I was talking about is corresponding. This is 63,43 and that's also 63,43 because the lines are parallel there. So that is 63,43 degrees plus 45 degrees, and let's see what answer we get. So we got 63.43 plus 45. I've got 108,43 degrees. 108,43 degrees. That's the size of FED. Right, so I hope you guys are understanding. Next question. We want to find, let's see what we want to find. G is a point on EAGC in that order is a parallelogram. Okay, in that order is a parallelogram. Determine the equation of the circle centered at G and passing through the point B. What are they talking about here? Let's see. Let's try to make sense of this problem. And what do they want? Alright, so first, G is a point such that EAGC. G is a point such that EAGC in that order is a parallelogram. EAGC. So we got EAGC. Where will G be then? EAGC. Won't G be here? G will be somewhere around here then. Because saying EACG, we don't want CG, we want GC. So we kind of, if you have to imagine this here becomes a diagonal. So G has to be kind of like on the x-axis because that's the next diagonal. Right, so let me just extend this to, right, so EAGC. What they mean here is that, let's draw this line here. Because it's a parallelogram, this line will be parallel to this line. And let me complete this parallelogram so it makes sense to you. Alright, that's the parallelogram they want. Right, so EAGC, EAGC. So remember, this becomes a common midpoint then. And let's see what answer they want. Determine the equation of the circle centered at G. The circle center is G and passing through the point B. Circle center is G. Now remember, what was the coordinates of E? Did we find the coordinates of E? Did we find the coordinates of E? No, we didn't. But we can find the coordinates of E and then we can get the coordinates of G. Right, so the coordinates of E will be making x0. So E will be, the coordinates of E is minus 11 and 0. Right, and what was the coordinates of B? Coordinates of B was, did we find that? I think we found coordinates of B. It was, what was B? B was 4, 0, right? So let's put 4, 0 here. Right, so no need to do midpoint because it lies on the x-axis because that's the diagonal. So we got minus 11 to 4, that is 15. And remember, the circle is centered at G and is passing through B. So that should become the radius then, okay? So that's basically the radius. Right, so this becomes the radius of the circle because center is G. Now, because this is from there to there is 15, this is a common midpoint. We need to go 15 across. So 4 plus 15 is going to give me 19. So the coordinates of G is 19, 0. Right, so we have the equation of the circle, x minus, and the radius is what? The radius is 15 plus 4, right? Which is 19. So we got x minus 19 all squared plus y minus 0 squared is equal to, what was the radius? The radius was 15, not 19, sorry. So it was 11 plus, radius was, made a mistake here, right? So radius is 15, yeah, radius is 15, which is basically 11 plus, remember E was 11, minus 11, in other words 11 plus 4, or 4 minus 11, right? So that is 15 squared. Do they want it in this form, or should we write it in r squared form? Yeah, well, they wanted it in r squared form, so I got 15 squared, and y minus b all squared is equal. Okay, so we can simplify this, right? X minus 19 all squared plus y squared is equal to 225, right? So I hope you guys understood that. Right, so that's my answer. Let's move on to the next problem. Should be grade 12 circle geometry now. Well, that was also circle geometry. Nice. This was also analytical geometry, testing on circles. Question 4. In the diagram, the equation of the circle centered at N is the center, is, now we are even given the equation of the circle. In other words, we can find the radius. The equation of the circle center M, so we got the center radius form, that's easy. So the radius over here of the larger circle is 5, right? The radius of the larger circle is 5, and the center M is minus 6, minus 3. Okay? PS and PR are tangents to the circle. PS and PR are tangents to the larger circle, as we see. Now PR and PS, so we know they are equal, tangents from common point. Also, PR is parallel to the x-axis, very important information. PR is parallel to the x-axis. Okay, they're parallel. Then K is minus 17 and 5, minus 5 is a point on PS. The straight line joining N and M cuts the smaller circle at T and the larger circle at S. Now let's read the first question. Write down the coordinates of M. Coordinates of M is minus 6, minus 3. Right? Coordinates of M is minus 6, minus 3. Calculate the length of the radius of the smaller circle. Calculate the length of the radius of the smaller circle. The length of the radius of the smaller circle is, you gotta complete the square here, okay? Right, so I'm starting off with this equation. I need to complete the square. Right, so we're gonna write x squared plus 24 plus something squared plus y squared minus 10y plus something squared is equal to negative 153 plus something squared plus something squared. I hope you guys are understanding this. Now what is that something squared? 12 divided by 24 divided by 2, so that's 12, minus 10 divided by 2, which is minus 5, and this is minus 10, so same, 12 and minus 5. Now what we have on this side is x, the value of this is just plus 12 all squared, plus y, the value of that is just minus 5 all squared. So we get this perfect square here. Negative 153, 12 squared is 144, 25, 144 plus 25 is 169. Yeah, what is this? Minus 5. So we negative 153 took that over. Let's work it out. Yeah, so we got 169 minus 153. It looks like it's 16. Let's check. Negative 153 plus 144 plus 25. So we have, wait, negative 153, right? So we got 16. So the radius is equal to 4. I hope you guys understood that. The square root of 16, which is 4. The radius of the smaller circle is now 4. Right? The length of TS. Now, how are we going to calculate the length of TS? So we're going to calculate the distance between the centers and minus the 2 radii to get TS. Right, so quite simple. Minus 4 minus 5 to get TS. So first we need the distance MN. So we need the distance MN. We're going to use the distance formula. Right, so remember what was M and N. Let me just write it here. M is minus 12 and 5. And N was minus 6 and minus 3. Let's just double check. N minus 6 minus 3. Right, now is x2 minus x1, so we got minus 6 minus 12, so minus 6 plus 12 all squared, plus minus 3 minus 5 all squared, minus 3 minus 5 all squared. So if I add up everything, 6 squared is 36, 8 squared is 64, 36 and 64 is 100, square root of 100 is 10. You should get 10. So remember, the entire distance is 10, so TS will now become 1. Right, because that is 4 and that's 5, so TS will become 1. Therefore TS is now equal to 10 minus 5 minus 4, which is equal to 1. Right, TS is equal to 1 unit. Moving on to the next problem. I hope you guys are understanding. Don't forget to leave comments if you're not understanding. Right, so determine the equation of the tangent PR. Equation of the tangent PR. We want to find the equation of the tangent PR. Now, to find the equation of the tangent PR, we want to see what's the y value there, because it's a horizontal line. Okay, PR is a horizontal line, so I'm going to drop this radius, right, MR, right, and you know that's radius perpendicular to tangent. That's going to drop by 5. So this M coordinates, the x value remains the same, the y value drops by 5. So it's going to, R becomes minus 6 and minus 8 because it dropped by 5. Okay, so what's the equation of a horizontal line PR? The equation of the horizontal line is y equals negative 8. Right, remember the equation of the horizontal line, y equals k. So in this case, y is equal to negative 8. What's the equation of PR? Remember to write down the coordinates of R, which is negative 6 and negative 8. Therefore y is equal to negative 8. Right, because we just dropped 5 units down. Remember, MR is equal to MS radii. We should write that down, should we? MR equals MS, that's radii. Yeah, let's continue with the next problem. I think we got enough information there. Right, so let's find the determine the equation of the tangent PR. Now let's find the equation of the tangent PS in the form y equals mx plus c. The equation of the tangent PS. Right, simple, because we got radius perpendicular to tangent. We can find the gradient of ms, which is the same as the gradient of mn. Right, so let's work with that. Let's take this diagram across into a problem. Let's take this diagram down to explain this better to you. Right, so what we have here is, first we're going to find the gradient of mn, collinear points. So gradient of mn, Right, so what's the gradient of mn? So y2 minus y1, so mn 5 minus minus 3. 5 minus minus 3 is 5 plus 3, okay? 5 minus minus 3, 5 plus 3 divided by minus 12 minus minus 6, minus 12 plus 6. So I've got 8 over negative 6, which is minus 4 over 3. Okay, so now the gradient of PS, now becomes negative reciprocals, negative 3/4, right? Because MS is perpendicular to PS. MS is perpendicular to PS. Why are we saying MS is perpendicular to PS? We should say that first rather. Why is MS perpendicular to PS? Because the radius perpendicular to tangent. Right, so we have that 90 degrees there. Radius perpendicular to tangent. Then are we going to say at K minus 17 minus 5. Right, so we got y minus y1, y plus 5 equals negative 3/4 into x minus minus 17, x plus 17. Right, so we're going to open this up. Right, so y is equal to, remember the 5 went over, minus 5, minus 3/4 x. 3 times 17 is 51, so minus 51 over 4. Okay, so we got y equals negative 3/4 x. So we want to check what's the value, minus 51 over 4 minus 5. Okay, so let's check on our calculator. We have minus mod 1 negative 51 over 4, right, minus 5. Right, so I'm getting an answer of minus 71 over 4. Let me just write it as minus 71 over 4. That's better. Right, so I hope you guys, we're finding the gradient of PS. Yeah, it's supposed to be positive sloping, so mistake here, because that's negative. It should be positive here. Positive. Yeah, so I was going to check that either way. So that's positive. That should be positive. Plus and plus here. So take out this negative. Should be positive. Minus 71 over 4. That's going to give me not minus 71 over 4 now. It's plus 51 over 4 minus 5 now. So no minus. That's a plus. Right, so that's giving me 31 over 4. That should give me plus 31 over 4. Yeah, I was going to explain that this is a positive sloping. Make sure your gradient is positive. But I checked that's negative. We made a mistake here. Right, so I hope you guys understood that. Remember, the perpendicular gradient is always negative reciprocal. So it's the opposite sign of this, positive 3/4. Right, so that's my answer. Moving on to the next problem, which is question number. We want to find the perimeter of PSMR. How are we going to find the perimeter of PSMR? Let's take this diagram and work with this again. So where is PSMR? PSMR. In other words, we want to find the distance around this entire thing. We got 5 and 5. So in other words, in order to find the distance, remember it's 5 marks. Let's find the coordinates of P. Because if you can get the distance of P, so we know that PS equals PR. Let's write this down. PS equals PR. Tangents from common point. Right, so that's tangents from common point. Now remember, we got the equation of line PS, right? We already have the equation of line PS, and the y value of P here is negative 8. So in other words, this is T. Let's just put let's call it x, or let's call it a. So if we can get the a value here, then we got the horizontal distance from there to there. Now let's try to work on this now. So let p be a and -8, and remember the equation of line PS, we just found that, which was 3/4 x plus 31/4, right? Plus 31/4. We're going to substitute this inside here and solve. So y is -8. We got 3/4 a plus 31/4. Now we're going to take this 31/4 over and divide it by 3/4. So I'm going to take -8 minus 31/4, right? I've got an answer, -63/4, and I'm going to divide it by 3/4, divided by 3/4. Right, so I've got -21. A is -21. Now I've got -21 here, right? So I've got -21 here. So obviously I can find this horizontal distance. We're going from -21 to -6. So we can say PR is now equal to -6 minus -21. So that's going to give me 15, because 21 minus 6. So that is 15 units, and now this is also 15 units. Right, so what's the perimeter? Perimeter is equal to 15 plus 15. 15 times 2 plus 5 times 2. So that's going to give me 10 and 30, that's 40 units. Right, so I hope you guys understood that. Right, so that's 40 units. Next question. So as you see, the problem is just getting more challenging, right? So let me take this a out now and put a value which is update our diagram. A was -21, okay? Because the next question is ratio of area of NPS. Where's NPS? NPS is to area of quadrilateral PSMR. PSMR. Now remember, PSMR is a kite. Right, so let me use this diagram, the updated diagram, and explain to you what's happening. Right, so nice questions here. So what we can see is we want to find the area of this triangle, the ratio of the area, right? So let's work with this triangle here first. Area of triangle NPS. NPS is here. Right, so we got NPS. Let me join that. But we don't need anything. We just need a half base times height. Area 1 is the top. Area of triangle NPS, okay? Area of triangle NPS is equal to half. What's the base here? The base here is 15, right? And the height is NS. NS is the height because we want NPS. Right, so 1 plus 4. The height is 5. Right, so we can take 5 times 15, which is 75/2. So what we have is 15 times 5, which is 75/2. 75/2 units squared. Then to find the area of the quadrilateral PSMR, how are we going to find the area of the quadrilateral PSMR? I think to find the area of a kite, you can just take the product of the diagonals. Or yeah, we don't need that. To find the area of this quadrilateral, we can draw the line. Draw line PM. Draw a line PM and work with that, and then we could. Yeah, it wasn't difficult. A straightforward problem, not difficult at all. Very nice problem though, something thoughtful. Right, so remember this is the center of the circle, so 1, and you got triangle, 2 triangles, right? So area is equal to, it's the product of the diagonal times half, I think, yeah. So you're going to take half base times height times 2. So you see half, what's the base? The base is, no, we don't need product of diagonals because we got 90 degrees, 90 degrees. Half, the base is PR, area of the second triangle. Right, so let's work this out. Area of quadrilateral, not the triangle, quad. Right, so now we're trying to find the area of the quad, which is PSMR, PSMR, PSMR. Right, so we're looking at half. What's the base here? PS times SM plus half PSSM and half PR times MR. So what we have here is half. What's PS? PS is, what is PS? PS is 15 and SM is 5 plus half PR. PR is 15 as well, and MR is 5. Yeah, so that's just going to give me 75 over 2 plus 75 over 2. It's just going to give me 75. Therefore, area of triangle NPS over the area of quad PSMR is equal to 75 over 2. 75 over 2 divided by 75, right? So that's just going to give me half. So that's 75 over 2 divided by 75. 75 cancels out, you just have half. I hope you guys understood that. Alright, so nice problem as well. I was just thinking about the properties of a kite, but the thing is, you don't have the coordinates of S. We could have took diagonals and worked it out, but quite challenging here to get S. We can get the coordinates of S and then work it out, but just leave it out. It's fine. But just check up the, you know, the if you can use the properties of a kite to use it. But that's going to give me, it's just 2 marks. So this way is way simpler. Right, so whatever thought comes to your mind first, try to use that. Or if you find a simple method in between, try to use that. Let's continue with question 5. In question 5, without using a calculator, simplify the following expression to a single trigonometric ratio. So we need to use a cast diagram here. Right, so sine of negative angle, that's in the 4th quadrant, right? So that's going to, remember, positive angle is going around, right? And negative angle, positive theta is in the 1st quadrant, negative theta is in the 4th quadrant. So we have 1 minus sine of negative theta is negative sine theta, right? And cos of 90 plus theta is in the 2nd quadrant, and because of the 90, cos changes to sine, right? So we have sine, negative sine theta, because cos is also negative in the 2nd quadrant, and cos changes to sine theta. Now cos of theta minus 360 degrees, we're just going to add a revolution. Okay, we're just going to add 360 because when the angle is negative, then we got cos theta. Right, so what we have is 1 minus, we got 3 negative, so we got sine squared theta divided by cos theta. Sine squared theta is 1 minus sine squared theta is cos squared theta, alright? From your identity, divided by cos theta. The cos and the cos cancels out, and we have cos theta. So we simplified this to a single trigonometric ratio. So that answer is correct. Now moving on to the next problem. So we have cos 20 degrees is equal to P. So you know that's a triangle problem, so we need to draw a triangle without using a calculator. Write each of the following in terms of P. So let's draw a triangle. We draw a right angle triangle because cos 20 degrees is equal to P. It's P over 1, right? So adjacent over hypotenuse. So make sure you complete the triangle completely, right? So in other words, fill in all the angles, all the sides, use Pythagoras, do everything. So we know that this is a right angle triangle, it's 20 degrees and it's P over 1. So adjacent hypotenuse. So the square root opposite will be 1 minus P squared. 1 squared is 1. And the top angle is 70 degrees. I hope you guys understood that. Now cos of 200 degrees is in the third quadrant, that is cos of 180 plus 20, and in the third quadrant cos is negative, so negative cos 20 degrees. So my answer is cos of 20 is P over 1, so negative P. Right, so I hope you guys understood that. Moving on to the next problem. Sine of negative 70. Remember, negative angle is in the fourth quadrant, sine is negative. So we get negative sine 70 degrees. Now sine of 70 is negative. What is sine 70? 70 degrees is here, opposite over hypotenuse, so it's P. Again, P over 1. Right, so far nice problems. Next one, sine 10. How are you going to find sine 10? Sine of 10 degrees using these angles. Right, so using this this triangle, how are you going to get sine 10? Sine of 10 degrees. Can we get 10 degrees by, okay, it's not a double angle because it should have been sine 40, right? So that's double angle, but so it's not a double angle. Right, so if you can't use angles of triangle addition and subtraction, move on to special angles. So if I use special angle, it's going to be 30 minus 20. So this will become sine 30 degrees minus 20 degrees, and you know 30 minus 20 is the angles of triangle, and 30 degrees is basically special angle. So expansion for sine is a compound angle, sine identity compound angle. So sine 30 cos 20, the sign remains the same, cos 30 sine 20, right? So sine cos, cos sine. Right, you can check that in your formula sheet, sine of A minus B. Alright, so sine 30 is half, cos of 20 is adjacent of hypotenuse P, minus cos of 30. Cos of 30 is special angle, which is root 3 over 2. You can check it up. Let's check what's cos 30. Cos of 30 degrees is root 3 over 2, right? And what is sine of 20? Sine of 20 is opposite of hypotenuse. So that is the square root of 1 minus P squared. Right, what we can see is the LCD is 2. Right, so LCD is 2. So we got P minus root 3, 1 minus P squared into 1 minus P squared. If you want, you can combine these two into a single surd. Square root of 3 minus 3P squared. Right, all over 2. I hope you guys understood that. Next problem. Determine without using the calculator the value of, right? So I think this is moving on to the separate problem because that was 5.2 triangle question. Right, so this is an independent problem. Let's solve this. Cos A plus 55, cos A plus 10, A plus 55, sine A plus 10. So you got cos, cos, sine, sine. So that's cos compound angle. That's your first angle here, right? And that's your second angle here. Can you see? A plus 10, A plus 10. So cos, cos, sine, sine. So that's cos A plus 55 degrees minus, take the opposite sign because expansion for cos. Only for sine, the sign remains the same. Anyways, this is cos minus A plus 10. Right. So what we got, A minus A cancels out. A and A cancels out. 55 minus 10 is 45. And cos of 45 degrees is 1 over root 2. If you rationalize root 2 over root 2, you can get root 2 over 2. Right, so straightforward, simple problem. Let's move on to the next one. Consider cos 2x sine 2x minus cos squared over sine x minus 2 cos x. Prove the above identity. Now left hand side is equal to, because we have cos 2x and we have negative cos x, so expand the cos squared in terms, expand the cos 2x, the double angle, in terms of cos x, in terms of cos and sine, because we got sine here as well. So I'm going to say this is cos squared x minus sine squared x, right? Sine double angle, I don't have a choice, it's just one of them, 2 sine x cos x, and the last one is just negative cos squared x, all over sine x minus 2 cos x. Now what we can see is that cos squared and the cos squared cancel out, and we can take out sine x as a common factor. If you take out sine x as a common factor, let's see what we get. Taking out sine x as a common factor, alright, we took out sine x as a common factor, we left with 2 cos x minus sine x. 2 cos x minus sine x. Alright, so 2 cos x minus sine x divided by, take out a negative from the denominator. If I take out a negative from the denominator, switch this around, 2 cos x minus sine x, right? And we can see that these two things cancel out, the factors, and we left with negative sine x, right? So straightforward problem as well, which is equal to RHS. Right, so that's proved. Moving on to the next one. Determine the value of this. Determine the value of cos 2x plus sine 2x minus cos squared x over negative 3 sine squared x plus 6 sine x cos x. Okay, to determine the value of this, how are we going to do that? Cos 2x, hence, because this is in that, I'm sure we should have a way to find the value of this. Alright, so what we can see in the denominator, focus on the denominator, we're not going to do anything on the numerator, because we want to try and incorporate this whole thing here inside over here, right? So we want to replace this entire left hand side with something inside here. So let's focus on the denominator. We're not going to change anything on the numerator. So the numerator remains the same, which is cos 2x plus sine 2x minus cos squared x. Now change the bottom. So I'm going to take out negative 3 sine x from the bottom. If I take out negative 3 sine x, I will have sine x minus 2 cos x. So I'm going to take out negative 3 sine x from the bottom, because that's the HCF. Then I will be left with sine x minus 2 cos x. Alright? Because 6 divided by minus 3 is minus 2. Sine x cos x divided by sine x is just cos x. Now what we see is, focus on this. What is this entire thing over here? We already know that this is negative sine x, okay? We already know that this entire thing over here that I've highlighted is basically negative sine x. So we're going to write negative sine x over negative sine x over minus 3 sine x. Now sine x cancel out, we left with 1/3. This is from question 5.4.1. right, we proved that. So my answer is basically equals to 1/3, because sine x and sine x cancels out. Right, remember we proved this, that this entire thing here is equal to negative sine x. So that's what I'm doing. I'm replacing this whole thing with negative sine x. Right, so all sorted. Let's move on to the next problem. Next problem says, given 3 tan 4x 5.5, given 3 tan 4x equals negative 2 cos 4x, without using a calculator, show that sine 4x is equal to negative 0.5 is the only solution to the above equation. So you need to simplify this equation to this, but we know what is tan, right? So we know what is tan. 3 tan is sine x, sine 4x over cos 4x, right? We know that. We know that is the tan identity. Tan is sine over cos. Negative 2 cos 4x. So what is cos 4x? Let's just leave it as cos 4x. Okay, now how will this help us? How are we going to simplify this? Right, to simplify this, we're going to cross multiply. Right, so let's cross multiply here. Multiply both sides by cos 4x. So we got negative 2 cos squared 4x, and on the left hand side I've got 3 sine 4x. Now what I'm going to do is, because I got cos and sine mixture, I'm going to replace the cos squared with 1 minus sine squared. 3 sine 4x minus 2 into 1 minus sine squared 4x. Right, so I'm going to expand this now on the right hand side. I've got, now you can see my I kind of have like a quadratic with everything in terms of sine x. Now on this side, on the right hand side, I'm going to open this brackets up, minus 2 plus 2 sine squared 4x. Alright, now I'm going to bring this onto the other side and write it in standard form. So I've got 2 sine squared 4x minus 3 sine 4x minus 2. Right, so I basically have let k be equal to sine 4x. Right, so this is 2k squared minus 3k minus 2. I have a quadratic to solve. Alright, now continue solving here. You're going to open up 2 brackets. That's equal to 0. You can only have 2k and k. And factors, you can't have a 2 there, then you can factorize another 2. So you have to have a 2 here and a 1 there. And we want minus 3k, so minus and a plus. So we got k equals negative half, or k equals 2. Now remember, sine 4x can't have 2. It can never ever be 2, because minimum and maximum value of sine is 1 and negative 1, right? So value of negative 2 does not exist, so not applicable here. So what is k? K is just sine 4x is equal to negative 0.5. So did we prove it? Yes. Sine 4x equals negative 0.5. That's what this trigonometric equation simplifies to. Very nice question. Let's move on to the next one. Hence determine the general solution of. So what we're going to say, this implies we're basically solving this, because this 3 tan 4x equals negative 2 cos 4x simplified to this. Sine 4x equals negative 0.5. Now we're going to work out reference angle. Reference angle is equal to 30 degrees. Now where's sine negative? Sine is negative in the 3rd and 4th quadrant. So quadrant 3 solution is going to give me, what's in quadrant 3? 4x is equal to 180 plus 30 degrees plus k 360. Don't forget to write k is an element of z, right? And we're going to solve for x. So we have 210 divided by 4. So what is 210 divided by 4? I've got 52,5 degrees plus k 360 divided by 4 is 90. Or we have quadrant 4 solution, which is 360 minus 4x is equal to 360 minus 30 degrees plus k 360, right? So x is equal to 360 minus 30 is 330. 330 divided by 4, I'm getting 82,5 plus k 90. So that's your general solution, two general solutions. I hope you guys understood that. Right, so perfect. Let's move on to the next question, which is trig graphs. In the diagram below, the graphs of f of x, which is tan, the graph of f of x, tan x minus 45 degrees. So the original tan graph is shifted 45 degrees to the right. Okay, so that's why it's moved from 90 degrees to 135 degrees, the vertical asymptote. Right, so write down the period of f. What's the period of the tan graph? From minus 45 to 135 is still 180 degrees. One full graph is still 180 degrees. So remember, the original period of tan graph is 180 and sine and cos is 360. I hope you guys understood that. Draw the graph of g of x. So we're going to draw the graph of g of x, which is cos of 2x in the interval minus 90 to 180 on the grid provided. So I'm going to draw it on this diagram here, and the graph is minus cos 2x, and the steps is 45 degrees. So let's use this mode, go to table, option 7. F of x is just tan x, so I'm going to leave that out. Right, press I'm just going to put 0. Right, f of x, actually just put f of x as g of x here. So minus cos 2 alpha x, right, close bracket, equals g of x, we don't want anything, minus 90 starting value, right, enter the value, end at 180, right, and very important is the steps. We don't want to step 1, we want to step 45 degree intervals. Now press equals, you get all the values. At minus 90 it is 1, at minus 90 it is 1, right, at minus 45 it is 0. That's a cos graph, right? At 0 it is minus 1. Then at 45 degrees it is 0. Then I think because it's symmetrical, at 90 you're going to get 1. Right? At 90 I got 1. At 135 I will get 0. And at 180 I will get minus 1. So 135 0. 180 I will get minus 1. So there's your graph here. Right, okay, so I kind of have like, obviously the graph will be turning like that. Okay, alright, that's a graph. You know, the cos graph is wavy graph, and then you're supposed to turn there. Right, so that's my cos graph. Please draw it in pencil. Right, so we've indicated everything, intercepts with the axis as well as the minimum and maximum points on the graph. There's the maximum, that's the minimum. Minimum at 0 and minus 1, maximum at 90 and 1. There's another maximum there, there's another minimum here. Right, anyways, that's done. Write down the range of g. What's the range of the g function? The cos graph that we just drew is only between minus 1 and 1, minimum and maximum value. So between minus 1 and 1, or if you like writing it like this, y is an element from minus 1 to 1. That's perfect. Right, the graph of g is shifted. The graph of g is shifted 45 degrees to the left to form the graph of h. Determine the equation of h in its simplest form. Now remember, you're shifting the graph of g 45 degrees to the left. So g of x, right, is equal to negative cos 2x. So we're shifting 45 degrees left. Then we're going to get a function h of x, which is g of x minus 45, not minus 45, plus 45, right? So h of x will become g of x plus 45, right? So now what is g of x plus 45? In the place of x, I replace it with x plus 45, so negative cos 2 times x plus 45 degrees, all still in brackets. Okay, now remember it's 2 times, so I replace the x with the x plus 45. Okay, so let's see what we need to do here now. right? So we're going to open this bracket up. 2 times x is 2x, negative cos 2x plus 90. Now 2x plus 90 is in the second quadrant, right? Cos in the second quadrant is negative, so negative times negative, cos becomes sine because of the 90, so it becomes sine 2x. Okay, so what's your function now? What's your function h of x? Your function h of x is therefore h of x is just basically equals to sine 2x, right? So determine the equation of h in its simplest form. The simplest form is just sine 2x. I hope you guys understood that. Let's see if this is correct. Cos in the second quadrant is negative, negative, cos changes to sine because of the 90, negative sine 2x, because this is 90 degrees plus the angle. Right, perfect. So everything makes sense. Now let's solve using our graphs. Let's solve these questions. When is f of x greater than 1? When is f of x greater than 1? In other words, we need to draw a horizontal line 1, and when is the function above 1? That's what they're asking us. So to solve that problem, we need to draw a horizontal line 1, right? And when is the f graph above 1? So we can see at 2 points, right? So at 2 points, which is above 1 after 90 but less than minus 45. It can't be 45, right? Because that's the asymptote. So from minus 90 to 45, and from 90 to 135. So we're going to write down those two answers. So what we said, minus 90 to 45, minus 90 to minus 45. X is an element from minus 90 to minus 45, round brackets, union means or. Second solution is from 90 to 135, 90 to 135. Right, and that's my answer. Next one, 2 cos 2x minus 1. 2 cos 2x minus 1. So how are we going to solve that? Use a graphs to determine the values of x in the okay, so because we only want this interval, watch the intervals. From minus 90 to 90, that's where we want it. So this answer won't be there, right? So we're not going to put this answer down. Just be careful. Please read the questions carefully. Right, 2 cos 2x minus 1. So we can say cos 2x is greater than, take the 1 over and divide it by 2. So take the 1 over and divide it by 2. Then what we need to do is make it look like g of x. So we're going to multiply both sides by negative. So negative cos 2x is less than negative half. Then we can see that this is g of x, right, less than negative half. So when is a g graph below minus half, the line minus half, right? So below minus half, the g graph, when is it below minus half? So I'm going to draw a horizontal line at minus half. Right? You know, but now you know cos of 60 is minus half, right? So remember, how are you going to get cos 60? How are you going to get, remember cos of 60 is half. So I'm looking at this line here. So obviously this line over here looks like is 30 degrees because 2 times 30. So remember cos of 2 times 30, mode 1, cos of 2 times 30 degrees. Right, so put a negative in the front and then you see you got negative half. So from 30 degrees when it is below minus half. So from 30 degrees to, what is this point now? What about this point here? That point will also be 30 degrees, right? So negative 30 to 30. Because we only want an answer between minus 90 to 90. So from negative 30 to 30, not including, negative 30 to 30. That's my answer. So the answer is x is an element from negative 30 degrees to 30 degrees. I hope you guys understood that. Now moving on to the next problem. Which is solution of triangles, right? In the diagram, A, B, and C are points in the same horizontal plane. Pretty straightforward, right? D is a point directly above C, so it's perpendicular, such that DC is perpendicular to AC, right? Same horizontal plane, and DC perpendicular to BC. It is given that ACB is equal to 100 degrees, which is the horizontal plane angle, right? CAD is 30 degrees, and AD is 20. AD is 20, so obviously you can find DC using this triangle here, SOHCAHTOA, and BC is 8. Once we find DC, then we can find these lengths here, this angle, and alright. So far, calculate the length of AC. To find AC, we're going to use triangle DCA or ACD, and we're going to use adjacent over hypotenuse. So cos 30 is equal to adjacent over hypotenuse, so 7.1.1. We're going to use cos of 30 degrees, right? 7.1.1, we're going to say cos of 30 degrees is equal to adjacent, which is AC, over hypotenuse, which is 20. So we're going to cross multiply. AC is equal to 20 cos 30. Let's put it onto the calculator. 20 cos 30. Cos of 30 is root 3 over 2, right? So you're going to get 10 root 3. Right, so I know what is AC, 10 root 3. What is AB? What is AB? So remember, this is 10 root 3. Now you got side, angle, side in the small triangle here in the horizontal plane, side, angle, side. When you have side, angle, side, we need to use a cosine rule. So AB is equal to, so 7.1.2. You need to say AB squared is equal to 8 squared plus 10 root 3 squared. Right, so let me write this at the bottom. Right, so 10 root 3 squared minus 2 times 8 times 10 root 3 cos 100 degrees. I'm just going to get all this on the right hand side and then square root the answer. So I'm going to say 8 squared plus 10 root 3 squared minus 2 into 8 into 10 root 3, right, close bracket, cos 100. Right, so I've got an answer of 412,12, and the square root of answer, I've got 20,3. So I know this is 20,3 units. Next one. If it is further given that ABD is equal to 73,4, ABD. So we're looking at this entire front face here, ABD. Right, so this entire angle over here is, that entire angle there is 73,4. Alright, that entire angle is 73,4. Calculate the size of ABD. So we want to calculate the size of ADB. And calculate that size, ADB. How are we going to calculate that? Alright, so we can use the sine rule, because we got this angle over the opposite side and this angle over the opposite side. So we can say sine D over 20,3 sine of ADB over 20,3 is equal to sine of 73,4 over 20. Right, so we can get the angle ADB by saying sine inverse of taking 20,3 sine 73,4 over 20. Alright, we just cross multiply, we get our answer and sine inverse answer. Right, so let's do that in steps. So we're going to say 20.3 over 20. Remember, we still got some stuff here. Sine 73.4 right, we get this answer and say shift sine answer. So I'm getting an answer of 76,58. Right, so that's the angle ADB. I hope you guys understood that. Moving on to the next problem, we into Euclidean geometry. In the diagram, O is the center of the circle. Very important information. If O is the center of the circle, then we have radii, okay? Also, we have angular center equals twice angular circumference. So we know this one is twice that, right? K, T, L are points on the circle. K, T and L are points on the circumference of the circle. KT, TL, KL, OT and OT are drawn. OK and OT are drawn. OT intersects KL at M. ST is a tangent. That's what we're looking for. ST is a tangent. Right, STK is 36 degrees. Now tan chord theorem, you know tan chord. Angle between the tangent and a chord is equal to the angle in the alternate segment is equal to angle L. So angle T1 is equal to angle L, which is tan chord. Then angle O is twice angle L. Angular center equals twice angular circumference. So I think most of the problems are sorted out. Right, so let's see. Determine giving reasons the size of angle T2. What is T2? To find the size of angle T2. That is simple because remember we have radius perpendicular to tangent. Right, so if that is 90, then first we need to write what we need to write for T2, 8.1.1a. So to solve part A, you want to solve for angle T2, you have to say OT is perpendicular to ST. And the reason is tangent perpendicular to radius, or radius perpendicular to tangent. Right, so then angle T2 is now 90 degrees minus 36. Right, so 90 minus 36, we can get the answer. 90 minus 36. Right, so which is 54 degrees. To find B, what's the next one? Angle L. How are we going to find angle L? That's tan chord theorem. Remember, we discussed that angle L is equal to angle T1, right? And that's equal to 36 degrees. The reason is tan chord theorem. Next one, we want to find the size of KOT. KOT, that's twice, right? So it's 36 times 2. So KOT is equal to 72 degrees. Angle at center equals 2 times angle at circumference. Right. So I hope you guys understood that. Just write the word full, circumference. Okay. Next one. Prove giving reasons that Km equals ML. How is Km equals to ML? Why is Km equals to ML? If Km equals ML, then we need to prove that this is 90 degrees here, right? So how can we prove that that is 90 degrees? How can we prove that that angle is 90? Okay, so we got angle T2, which is 90 minus x. 90 minus x. Okay, so we can see angle OMK. Angle OMK is 90. Angle OMK. Right, so this is the second part I'm doing. Angle OMK 8.2, 8.1.2. Let's bring this diagram down. Right, because I need to explain it to you. Right, so that's much better. Right, so let's do this. Now remember, we want to prove that Km equals ML. So we can say KML, KMO. KMO is equal to 90 degrees. How we got 90 degrees? 180, sum of angles of triangle. So remember, this was 76. You can see 76, it was 72. Wasn't 76, this was 72, 36 times. Yeah, remember this was 36, angular center, so this is 72. 72 and 18 is 90, so KML is 90, KMO is 90. And that's sum of angles of triangle, OMK or KMO, right? Now because that is 90, you can say KM. This implies KM equals ML, right? Line from center, perpendicular to chord. Right, so I hope you guys understood that. Pretty straightforward. Let's move on to the next problem. Next problem is on, I think, ratio and proportion. We can see what's given here. Right, so what's given here is in the diagram RDS is drawn. Let's put it in the side here. Right, so RDS is drawn. A, B and C are points on RD, RS, DS respectively, such that AB is parallel to DS. Now because we have parallel lines, alright, so make sure to extend the parallel line here as well. Parallel lines. Now you can't assume that this is a parallelogram. We don't know that. Alright, so remember, these are important information. RB to BS is 5:3. RB to BS is 5:3. So write 5x is to 3x. 5:3. DC is 20. Right, and CS is 12. Okay. Right, so question number 1. Where's question 1? Right, so let's just put this up. I'm sure we can prove both now. Alright, so prove giving reasons that BC is parallel to AD. Why is BC parallel to AD? How is BC parallel to AD? Prove giving reasons that BC is parallel to AD. How are we going to prove that? We have this triangle over here, right? We have this triangle here. So what we can say is, in order to prove that BC is parallel to AD, okay, BC is parallel to AD. Think about this, trying to prove that and that. So let's say RB over BS, RB over BS, yeah, we can say that 8.2.1. RB over BS is equal to, what is RB over BS? 5/3. And remember, we took RB over BS. Now we need to take SC over CD. We kind of proving like the converse of the prop theorem, right? So we're going to say SC over CD, which is 12 over No, 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 not SC over CD. It's the other way around. CD over SC. Because I'm trying to choose these two lines. Right? This one and this one. So we said RB over BS. We need to say DC over CS. So that is 20 over 12. And 20 over 12 is also 5 over 3. Divide by 4, divide by 4. So this implies RB over BS is now equal to DC over CS. Therefore we have BC, which is parallel. Then we can say that these are parallel lines. Now we have a parallelogram. Therefore BC is now parallel to AD. BC is parallel to, should say BC is parallel to RD. Right? And the reason for that is converse line parallel to one side of triangle. Or you can say sides in same proportion. Right? Or you can say sides in same proportion. Therefore now BC, because it lies on the same line, BC is now parallel to AD. Because these points are collinear, it lies on the same line. Now, if it is further given that RD is equal to 48, remember RD is now 48. Okay, now let me retake this diagram, because we're doing the second part, 8.2.2. Right, so 8.2.2, if it is further given that, see what it says. Right, so we know there are parallel lines here as well. We just proved parallel lines here. And this is in the ratio 5x is to 3x. Right, 5 over 3. Now, RD is 48. RD, the entire distance, RD is 48. RD is, calculate giving reasons the value of the ratio AD is to AB. When find AD is to AB. Right, so well, we know AB is already 20. We just need to calculate the distance AD. To calculate the distance AD, we're going to take the whole thing, RD over AD, or AD over RD. AD over RD is equal to BS over RS. Right, and this is from prop theorem, because AB is parallel to DS. Right, now we're going to take RD across, so AD is now equal to, what's RD? RD is 48, and what is BS over RS? BS is 3 over 8. 8 and 48 cancel out 6 times. 6 times 3 is 18 units. Right? 18 units. Now we can say AB is equal to DC, which is equal to 20, because opposite sides of palm ABCD. Right, so far it's good. Opposite sides of palm ABCD. And now what we can say is AD to AB is now equal to, what's AD? AD is 18 is to 20, which is 9 is to 10. Right, so I hope you guys understood that. 9 is to 10, that's a ratio. simplified ratio. Next question. In the diagram, O is the center of the circle, ABCD is a cyclic quadrilateral. Right, so use the diagram in the answer book to prove the theorem which states that opposite angles of a cyclic quad are supplementary. That is, prove that angle B plus angle D is equal to 180. Right, so first what we're going to do is draw construction lines. You must construct lines when you're proving theorems. So join line AO, draw line, construct lines AO and OC. Construct lines AO and OC. Therefore AO is equal to OC. Construct lines AO and OC and label O1 and O2. Construct lines AO and OC. Remember, AO is equal to OC radii. Right, so there's a proof here. We're going to say let angle A be equal to X. There's no angle A, it's angle B. Let angle B be equal to X. Right, so what's angle O1? Angle O1 is equal to 2x because angle at center equals 2 times angle at circumference. Right, so angle O1 is 2x. So what's angle O2? Angle O2 is 360 minus 2x. Okay, angle O2 is 360 minus 2x. Let's take this question up. Right, so why? Because this is angles around a point or revolution angle. Okay, so now we have 360 minus 2x. Therefore, angle D is now equal to 180 minus x because angle O2 is 360 minus 2x and angle D is half, so that should be 180 minus x, and that's angle at center equals 2 times angle at circumference. Right, so what did we prove now? Opposite angles are supplementary. This implies angle B plus angle D is now equal to x plus 180 minus x, which is equal to 180 degrees. Therefore, so we basically proved it. Therefore, angle B plus angle D is now equal to 180 degrees, and that's the proof. Right, so if you put an x somewhere, just try to reason it out using the x. Right, so that's how I like to prove it. I hope you guys understood that. Alright, so let's move on to the next problem. Next problem is, I'm sure it's application of what we just did now, but we already, cyclic quadrilateral. Right, so in the diagram, DEFG is a cyclic quadrilateral. DEFG is a cyclic quadrilateral. So we can see that if angle D1 is x, angle F is 180 minus x. Right, and then EF is parallel to DG. H is another point on the circle such that DH is parallel to FG. Chord EH is drawn. Let angle D1 is equal to x. So all we know is that angle F is 180 minus x. We have parallel lines here, okay? So parallel lines, I'm sure we can take an alternate here. Angle D2 is equal to angle G. What else? Angles in same segment. Can we do angles in same segment? So angle H, and this is going nowhere, right? So that's not helpful at all. Proof giving reasons that angle D1 equals angle D2. How is angle D1 equals to angle D2? We can do angle ascent, we can do angles in same segment this way. Ah, yes. Look at this chord. Remember this chord here. Right, so if you think about that chord, no, not that chord. I was looking at this chord rather. Going there, okay, and then this chord goes nowhere. Okay, so that's not helpful. What we can do at the moment is angle F, right? We got angle F here, which is 180 minus x. We can work with that first. Yeah, let's write angle F is 180 minus x. That's because opposite angles of cyclic quad, EFGD or DEFG, right? So that's 180 minus x. Angle G is now x. Why is angle G equal to x? Oh yes, and then we can take alternate. Angle G is x because co-interior angles. Angle G is equal to x because co-interior angles. Why is it co-interior? Because EF is parallel to DG. Right, so now problem solved because now we can do alternate. Angle D2 is equal to angle G is equal to x because alternate angles. Why is it alternate? Because DH is parallel to FG. Right, so this implies angle D1 is now equal to angle D2, which is equal to x. So both of them are equal to x. Right, so I hope you guys understood that. Right, so perfect. Nice problem so far. Now question 10. Is this a final question? Yes, it is. Alright, so let's see. Oh, 17 marks. Alright, so let's see what this question entails and what they're talking about here. So question number 1. Let's put this question 1 here. Alright, so let's see what they're talking about. In the diagram, TR is a diameter. TR is a diameter. Now since that's the diameter, remember that angle is 90 and that angle is also 90. Okay, so we got 90 and 90. So this entire big triangle is a right angle triangle. Perfect. And this small triangle is a right angle triangle. PRKT is a cyclic quadrilateral, as we can see. Alright. Chords TP and KR are produced to intersect at S. Chords PK is drawn such that PK equals TK. We know that PK equals TK, so we can have base angles of isosceles triangles equal, right? And we know that TR is a diameter. We don't have any tangents, so can't do really much there. Right, so first one, prove giving reasons that SR is a diameter of a circle passing through points SP and R. So there's basically a circle passing through SPR. Well, angle P1, P2 is 90, so P3 will be 90. So converse angles in a semicircle. So let's write that out first. So what we can say is angle TPR is equal to 90 degrees. Why is TPR equals to 90? TPR is equal to 90 degrees is because angles in a semicircle. Then we know angle P3 is equal to 90 degrees because angles on straight line (90°). This implies SR is a diameter. SR is a diameter because we got a 90 degrees. So SR has to be the diameter, and the reason is converse angles in a semicircle. Right, so I hope you guys understood that. Converse angle in a semicircle. Next one. Should be angle in a semicircle, not angles. Converse angle in a semicircle. Right, now next question. Prove that angle S is equal to angle P2. How is angle S equals to angle P2? How is angle S is equal to angle P2? I would say let angle S be equal to X, alright? Now prove that P2 is X. So this is X. How is angle P2 equal to X? That's what we want to try and find out. We can say angle R1 is 90 minus X because sum of angles of triangle. So angle R1 is equal to 90 degrees minus X. Sum of angles of triangle SPR. That's 90 minus X. Alright, then this angle is also 90 minus X because exterior angles of triangle is equal to interior opposite angles, or you can say sum of angles of triangle of the big one. We can say angle STK. Angle STK is also 90. STK. Because that is sum of angles of triangle STK. Right, so I just use sum of angles of triangle. But now you can clearly see that this is 90 minus X, that is 90 minus X. Now remember this was an isosceles triangle, so angle P1 is also 90 minus X. So now angle P1 is equal to 90 degrees minus X because angles opposite equal sides. Right, so this is also 90 minus X. Right, so we got enough information. Right, so we got 90 minus X there, so obviously angle P2 is now equal to X. This implies, therefore angle P2 is now equal to X. What do we call this? That's complementary adjacent angle. Complementary adjacent angles. Right, so this implies angle S is now equal to angle P2 is equal to X. Right, so straightforward problems, guys, not so difficult at all. Right, so you just needed to use what was the information given, and we have so many right angle triangles, so I'm sure you won't manage. Right, and next one, you want to prove similarity. So let me just take the same triangle here. Let's try to get it back into the picture. Take this triangle with all that information we have and try to prove similarity. Right, so and prove similarity here. Let's put this triangle in the side so you can have a look at the triangle as I'm solving. Right, alright, let's put it here. So first we have to say in triangle SPK and PRK. So SPK and PRK. So SPK is the big one. SPK, first triangle, and PRK, that's the second triangle. Right, 1 and 2. So SPK in triangle SPK and triangle PRK. PRK. Right, so reason number 1, SPK. So remember, angle P3 P2 is equal to angle R2 R3, isn't angle R2 R3, which is this triangle here, and that's the angle of that triangle, because angle P2 is X. So angle P3, let's work out R2 R3. Angle R2 R3 will be PRK. Angle PRK is equal to 90 degrees plus X, because remember, if this is 90 minus X, that has to be 90 plus X, right? That's the angles on straight line, right? Now we know that angle P3 is 90, so angle SPK is also 90 degrees plus X, right? And that is just sum of angles. So this implies PRK is now equal to SPK. Right, so I've got that part sorted out, those two. Let's observe angle K2. What is angle K2 equal to? Right, so remember, this is 90 plus X. So in this triangle here, PRK, I've got angle P2, I've got angle, okay, so now we can say angle P2 is equal to angle S. Both of them are X, right? That's proven above in question 10.1.2. Did we prove it? Did we prove that angle P2 is equal to angle S? Yes, we did. Angle P2 is equal to angle S. So we're using that information, X and X. Right, and the last one is angle K2. Last one is angle K2 has to be equal to angle K2 has to be equal to angle, oh, angle K2 is just common. Angle K2 was a common angle. Yeah, angle K2 is a common angle. Angle K2 is common. Angle K2 is common, so I didn't really see this, but now I'm seeing it because it's common to both. Alright, so we could have just used that and there was no need for that first one, but it's fine if you did that, because that's what I saw. So basically what you see first is just use your you won't get marked wrong, right? So therefore triangle, so these two triangles are similar, therefore triangle SPK is now similar to triangle PRK, right? And is angle, 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 right? So I hope you guys understood that. SPK is similar to triangle PRK. Now the last question, I hope it's not difficult, right? So if it is further given that SR equals RK, prove that ST equals root 6 RK. If it is further given that, I need that original diagram. There's too much of information here. Let's take the original diagram. Let's solve it using this. Alright, so what's the further information given? SR equals RK. We know that SR is equal to RK. SR is equal to RK. Let's call it Y and let's call it Y. So we can say let SR be equal to RK is equal to Y. That's given. Okay. So I called it Y. Right. SR is equal to RK. That's given. Right, so we have ST and RK. Now let's look at RK here. I'm using my similar triangles. I have to use similar triangles somewhere. Alright, so we know that this here has to be a reason for choosing my, the ratio. So this is my reason. So if I choose RK, I do need RK and I need ST. I need ST. ST is this big one here. Oh, okay, wait. Let's put all our 90 degrees as well. That was a 90. There was a 90 there. There was a 90 there. Alright, so that's what we have. We have 3 right angle triangles. SPK. Alright, so we are working with RK. We know we have to take those two ratio. We have to take PK over RK. And what's the other one? We have SR and RK. SR and RK. So we can take SK, okay? So let's start with SK over PK. I'm just trying this out. SK over PK. That will be nice because SK and PK, both of them appears inside here. So we got SK over PK. SK over PK equals SK over PK equals PK over RK. And that's the reason. If you cross multiply, you're going to get PK squared equals SK RK. Right, so cross multiply, okay? SK RK. PK squared. PK squared equals SK, but now we need to incorporate ST inside. Okay, if you incorporate in ST inside using SR, we can use Pythagoras because remember TK is equal to PK. So let's use Pythagoras in the big triangle. So you can say ST squared, and we need ST, alright. ST squared is equal to ST squared is equal to TK squared plus TK squared plus SK squared. That's Pythagoras theorem. But we have, what do we have? We have that PK is equal to TK, but PK, don't need to write that down. Let's just replace TK with PK squared. This is from because PK is equal to TK, and that was given. Alright, but now PK is SKRK. PK is equal to PK squared is SKRK plus SK squared. Now remember what was SK? SK is 2y times RK. What's RK then? RK is just y. SK is 2y, RK is y, plus SK is 2y all squared. So what do we have? We have 2y squared plus 4y squared, which is 6y squared. Now if we square root both sides, this implies ST is now root 6y. I square root both sides. Root 6y, and what is y? Y is either SR or RK. So I'm just going to replace y with RK. Root 6 RK. I hope you guys understood this, right?